Now let us talk about the very simple differential equation where the left-hand side is the derivative of the unknown function and the right-hand side is some constant times the unknown function. Right? So if the constant is positive, like in this scenario of population growth, then the solution is going to be well, a growing exponential function. And of course, the limit of the exponential function as t approaches infinity is also infinite. So, for instance, it means that as time goes by, the exponential growth of a population is not a realistic scenario. Okay, so but we're going to discuss how to make it more realistic a few minutes later. But now let us see what's going to happen if the constant here is negative, right? So if the constant here is negative, then the main scenario that it models is nuclear fission, right? So in physics, according to the law of nuclear fission, because of radioactive decay, the amount of substance it just gradually decreases over time, and the rate of change is also proportional to the amount of material, but only with a negative coefficient. Right? And this model is already quite precise because, you know, what it tells us is that if we have, I don't know, a bucket of plutonium, then in a matter of thousands of years, or, well, depending on the isotope, as time progresses, this plutonium is going to decay, which is true. And this is already a very precise model, is very stable. As t approaches infinity, there is no problem. It is still makes perfect sense. Now, here is a simple application in practice. Right? So, what this differential equation is capable of doing. So this is it is used in radiocarbon dating. So the thing is that organic materials, they contain two carbon isotopes. So one is stable, C12, and another one is unstable, radioactive isotope, C14. Well, and C14, it is present in the Earth's atmosphere, and it is accumulated in our bodies as we live. But when we die, it stops accumulating and it starts decaying. Right? So, which means that if some tissue comes from, I don't know, from an alive person, then there's supposed to be so much of C14. But if this tissue ages, then this C14, it just gradually disappears. And comparing how much it is actually present with how much it would be present if the tissue were alive, we can calculate the age of the tissue. I mean, the time when it was separated from a living organism or when the organism died. So here is the comparison. So direction field of the differential equation of exponential growth and decay, depending on whether the constant is positive or negative. So if the constant is positive, then we have exponential growth. So all solutions are growing exponential functions. So the limit is infinity as t goes to infinity. And if the constant is negative, then the limit is 0. So all solutions, they approach the 0 solution. So in a few minutes, we will see that this situation is called unstable equilibrium, unstable. So unstable meaning that different solutions, they drift away from the equilibrium. And in this situation, the equilibrium at 0 is called stable. Alright, I hope this is clear. So now a little quiz for you to recap the